Thank you for giving me this opportunity to present at the KIBIM International Symposium 2020. I am especially thankful to Professor Shin from Jungwang University. Our company philosophy focuses on enhanced quality of living through innovative technology. Introduction of our company. HISYS has revolutionized the global 3D printer market for construction in and beyond Korea. Based on our reliable technology, we will make the construction industry safer, more cost-efficient, and precise based on our reliable technology. The photo on the right shows our headquarters in Seoul, Korea. Slide 3 to 6 shows our company history. You may wish to read through these later. Due to limited time, I will skip these slides. Our major shareholder is Hyundai BSNC, an affiliate company established by a member of the Hyundai Group. As the CEO of HISYS, I have a breadth of experience and knowledge in engineering, having invented many innovative products including flexible touch panels and wearable displays for Samsung and LG. I have also developed automation production lines, electrical vehicles, and prototype robots, and also underwater robots, subwater devices, and automated transportation systems. Additionally, I have supported artists with the development of their sculptures and animation figures. Let me introduce you to our 5 core businesses: 3D civil engineering and construction projects, drone taxi development, hydrogen fuel development, waste plastic recycling, and aquaponics for the aquaculture industry. According to the reports by Smart Tech Publishing, the 3D construction industry will grow to about $40 billion in total annual sales in the future. There are 5 advantages to using 3D printing construction technology: customized designing, reduction of material use, time efficiency, reduced labor, and waste reduction. As you can see, septic tank production work that used to take 7 workers 7 to 10 days to complete can now be completed by 1 worker in 4 hours through 3D printing construction. Examples of 3D printing construction overseas includes the Dubai International Financial Center, which took 19 days to build at a cost of $140,000. This slide shows the latest advancement in development of 3D printing construction in Belgium. The capacity of this machine produced approximately 70 square meters of building coverage area for each story, up to 2 stories. To build a 3.3 square meter area using concrete, the material cost will be only $18 through 3D printing. Inevitably, the cost efficiency will be higher. This slide shows the development of our NC 3D printers. Our first prototype was built in 2018. We have currently developed version NC 1-1 and will reveal our latest model in 2021. Our NC 3D printers are developed as gantry type models for easy movement. efficient assembly and dismantling, and enhanced accuracy. It is made to endure outdoor operations. NC1 was built in 2018 and is the first prototype of our 3D printers. The photo shows the main body of the gantry type model, including the nozzle, discharge unit, mortar mixture, and control unit. The gantry model allows for efficient assembly and dismantling, and enhanced accuracy. It is made to endure outdoor operations. This video shows part of the construction process using NC1. The first part of the video shows the escalation process using cement mortar. In the next part, using red clay loess, and in the last part, white cement to build up the columns. The escalation of a precast block takes about 1 hour per pyong, which is 3.3 square meters. The precast concrete is produced as blocks into which anchors are embedded for easy transportation. This video shows the escalation of a 3D high-strength concrete pillar, UHPC, made of cement and sand. The printing time to produce a twisted column of about 3 meters takes about 2 hours. As you can see, NC1 can produce twisted columns of various forms. NC1 can be used to produce the shell of red clay saunas, which are very popular in Korea. Even the Buddhist monk is highly satisfied. A red clay sauna for 6 people takes about 3 hours to build. You may wish to view the next few slides by yourself for more details. "3D printing construction will be instrumental in the future for humanitarian projects. The layered wall of a typical movable homeless shelter for 5 people can be escalated within 4 hours. HISYS has been designated as a development and exchange partner with the Korean Navy 2nd Air Force Construction Battalion for future developments. Our NC1 model has been transported onto the military site to produce various supporting facilities. As you can see, we have produced military bunkers and protection facilities in barracks. The next video shows the production of 3D printed military bunkers again, using cement and sand. The printing time for escalation a typical bunker shell takes about 5 hours. As you can see, we can add rebar placements and bolt fastenings into the concrete shells to reinforce concrete columns for enhanced structuring. Architectural work is not just limited to buildings. Keel block guard posts and barriers on battalion ships can also be produced using our NC1 models. To symbolize partnership with Hyundai BSNC, our first mini project was to build a security office. Other examples of our 3D printing construction includes the Gwangju Biennale symbolic sculpture and the world design of DLH Sejong City Central Lake Park, PR booth. The NC1-1 is our latest model produced this year. The improved composition of the raw material supply pump system, stirrer, ladder, pad, nozzle, and other parts has meant that we now have the ability to work more flexibly on construction sites. When assembling and dismantling the printer despite its increase in size. Inevitably, the output size is also bigger by almost double. Precast blocks can now be escalated as large as 12 meters in width by 12 meters in length by 12 meters in height. Almost 10 domestic and foreign technology patents have been verified for the core technologies of our 3D construction printers. Additionally, about 20 more patent applications are currently in progress. Our NC1-1 is currently being reviewed for the Guinness Book of World Records as the biggest innovative 3D printer for architecture. This slide shows the assembly of the NC1-1. The following video shows the assembly and dismantling process in greater detail. Our NC2 printer model will be revealed next year. The biggest advantage of the NC2 is that it is slightly lighter in weight and is foldable. This will greatly simplify the mantling and dismantling process, as well as the transportation process. Again, improvement of the installation process is one of the key focus of our development for better flexibility of use on construction sites. We have embarked on an agreement with Kudo, a reputable German company that approached us for the development of 3D precast shells for their living units. As you can see, some units are double-deckers, others are single stories. Our plan is to establish an automated production line to produce these shells for Kudo. Here are more examples of the Kudo architecture. We have been commissioned by Korea Land and Housing Corporation, a government subsidized company, to build public toilets in a public park in Hanam City. These will be completed at the end of 2020. As you can see through the slides, there are many more projects ongoing. This particular project is again on Korea Land and Housing Corporation commission for the Sejong Smart Forest Town in Korea, including an aquaponic aquarium. One of our most exciting projects is to support the DFMA project using 3D printers and robots. The inventive technology in application for this project allows for the designing of complex motifs on bridge columns and other civil engineering structures. We can reinvent classical relic designs that can be used for restoration and preservation of prehistoric architecture in future. The preferred printer for this project is the robotic construction printer, not the gantry type, as the accent is on details and not on the magnitude of project size. Another high-profile project is with Daewoo for the production of a prefab automation system to make prefabricated concrete slabs for bridge girders. There are 7 phases to the prefab plant core process facility. The batch plant stores, mixes, and transports the concrete mix. The mold base shapes the concrete slabs and also accommodates the rebar placement. The concrete distributor is self-explanatory in that it helps to pour buckets of concrete into the mold. The surface finishing machine comprises abrasive equipment for smoothing and flattening the surface of the molded slabs of concrete. The deconstruction system helps dislodge and deformate the slabs produced and includes a tilting station. The final phase is for removing foreign substances from the slab surface through speed cleaning and other means of washing. Future development of our NC 3D printers is to advance from the gantry type 3D printer to the robotic prototypes. We anticipate the production of a combined multi-joint robotic arm and gantry type method printer next year, subsequently progressing into the development of the infinite orbital type robotic arm mobile equipment, which will greatly increase mobility and flexibility. Our target in future is to progress from the low aesthetic and functional building markets with a limited time and budget to much more sophisticated designs and structures using 3D printing, not merely as a means for cheaper alternatives, but to incorporate its true strengths into the evolution of an unforeseen classification of architectural developments. As Bill Gates once said, humanity's greatest advances are not in its discoveries, but in how those discoveries are applied to reduce inequity, whether through democracy, strong public education, quality health care, or broad economic opportunity. Reducing inequity is the highest human achievement. I believe that the role of our 3D construction printers in future humanitarian projects will resonate the ethos of the greatest corporates in the world. Thank you.